Hi guys, do you know what this is? This is the last section that we have to cover this year. Yay! I know you're celebrating. I am. This is awesome. Okay, and it's spheres. And keep in mind in the last little bit we've done area, and then we did surface area, and then we did volume, but we skipped spheres that whole time. So today we're actually going to do surface area and volume both for a sphere. And you probably know this, but a sphere is the set of all points in space that are the same distance from a center point. So if I held a string right here at this center dot with one hand, and then with my other hand, I went to the other end of the string and circled my arm around in any direction from that point that I had, just holding that one center perfectly still, that would create a sphere. If we hit every point that same distance from that center all the way around. So it's a radius from the center to the edge, and it's the same distance that way, same distance that way, same distance from that center, that radius every way, but not just two-dimensionally. It's also going out towards you. It's going up a little bit in all directions. Okay, the formula for the surface area of a sphere is 4 pi r squared. Okay, so that's a pi. I know it looks a little funky, but 4 times pi r squared is the surface area for the outside of that sphere. And I did put a little video here. You can't see it on my paper, but it should be on yours in case you want to watch somebody kind of work with a sphere and see how that goes together. The other one we want to look at is the surface area of a hemisphere, which is exactly half of a sphere. This one's a little bit different. So we would want to do half of this, right? We've got that whole outside, but we just want half of the outside. But then the other thing to think about is that it has this flat part on it, which also has area, surface area. So the way to find the surface area for a hemisphere, we're going to say that base or that center piece plus 1/2 of the surface area of the whole sphere. So you got to take half of that and then add that circle that kind of like caps it off. Okay, let's try these. Surface area. Here we have a sphere. There's the center, a radius of 12 meters, and that means it's 12 meters to the edge of in every direction of that sphere. And we find the surface area by doing 4 pi r squared. There's really only one number we need to stick in there, and that's the radius. Pi is a number, so we're not worried about that. So 4 times pi times that radius, 12 squared. Grab your calculator. Let's see what we've got. 4 pi times 12 squared. Okay, check and make sure that you can really get your calculator to say that you're typing everything in correctly. 1,809.6. And those are millimeters squared. Now we've done surface area, we've done volume. We just finished doing some volume where it was cubed, but now we're back to surface area, so it is squared. Okay, all right. Now I think these take a little bit more work. We've got a hemisphere. So we want to do this kind of a thing to it. We need half of the outside outer shell, and then we also need to figure out what that flat circle is that is bounding the bottom. This time he's laying down, it looks like. So first let's work on the sphere part, which is 4 pi r squared. That gives us the whole thing as if it were a complete sphere. 4 pi, the radius, they didn't give us a radius. They told us a diameter, and we know how to cut that in half and get our radius. Okay, let's put that in our calculator. 4 pi, and then times 4.5 squared is 254.5 centimeters squared. So I'm going to put a little line under that one. That is the entire sphere. Remember, we're only going to want half of that. But next, let's work on that base, or that flat complete circle that cuts it in half. And that circle is pi r squared. Do you remember doing that one when we did circles? Yeah. What we need to plug in is the radius. And again, they didn't give us that, but we can figure that out. 4.5 squared. Let's find out what the area is of that circle, that base part. So pi times r squared. Did you get 63.6? Okay, centimeters squared. So we've got 2 parts here. Now let's work on the hemisphere. So we would want to do the base plus 1/2 of the surface area of the sphere. And that base is 63.6. 1/2 of 254.5. Throw it in the calculator. Plus, now you can do, I'm going to do 0.5 for half. You could type your 1/2 in there. You probably want to put parentheses around it just to be really careful and keep everything separate. Okay, check and make sure you can get 190.9. We're rounding everything to tenths. Centimeters squared for the hemisphere with a 9 centimeter diameter. Okay, that's how you do it. Surface area for the 2. I want you to pause your video and try these next 2. You've got one that's an entire sphere and one that's a hemisphere. Then come back and we will check. Okay? All right, I think we're ready. So surface area of a sphere is 4 pi r squared. 4 pi. Now it looks like they gave us a diameter, so it goes across the center at the greatest part, and half of that is 3.5 squared. Let's check and see, did you get, that was not what I meant to push. Pi, 3.5 squared. Did you get 153.9? And these are inches and they are squared. Okay, surface area for that sphere right there. Awesome, let's try, now we've got another hemisphere. So we've got to do a little bit of extra work. We want to find half of the whole sphere with a 3-foot radius, and then we need to find the area of that circle. So I'm going to start with the whole sphere. 4 pi r squared, which is, hey, they gave it to us, 3 squared. Nice. Let's see. 4 pi, 3 squared, 113.1 feet squared for the whole thing, if there were 2 of them, right? Okay, base, it's a circle, so pi r squared, and we know that's 3 squared. So let's put 9 pi in our calculator, 28.3 feet squared. Okay, we've got the 2 pieces we need. Let's put them together. For the hemisphere, it's the base, the circle, plus half of the outer surface area if it was a whole sphere. 28.3 plus 1/2 of 113.1. So did you get 84.9? 84.9 feet squared. There it is. Good, good. All right, let's turn this over and take a peek at the back. So here we go. We've done surface area. Now we're going to do volume also for a sphere. And then you will have covered surface area and volume for all the same shapes through these last few units. Okay, interesting what the formula is for the volume of a sphere. Think about what we did for the surface area. Some of these numbers are going to look the same. It is 4/3 pi r cubed. So think about that like it's in 3 directions, right? Now we're doing volume. We're not just doing a flat surface area. We're looking for how much can fill up this sphere. So, and then the 4/3 is kind of interesting too. 4/3. And I think I linked a video on yours if you're interested in how that works out. But let's try it. We've got a sphere, 12-meter radius. So to find the volume, 4/3 pi r cubed. Only thing we really need to plug in is that radius. Everything else is either a number. Oh, is a number. 4/3 pi. Our radius is 12 and we're cubing it. Aren't you glad we have calculators for stuff like this? Okay, 4/3. So I'm going to put 4/3 in parentheses just to be super careful and keep everything neat and clean. Pi and then 12. Now, there are a couple different ways you can put cubed in your calculator. You can hit that up arrow right there above the division sign and then type a 3. On the newer calculators, it actually puts it up as an exponent. It's really pretty and nice. Another way is to push your math button. And the third one is to cube something, in case you want to use that way. Does the same thing though. So we want to cube our 12, hit enter. You should get 7,238.2. And I do want you to try that and make sure that you can get your calculator to give you that correct answer. Now, it's meters, but what little exponent am I doing? Think about that. We're back to volume again. Yeah. Okay, so with spheres, you're going to be popping back and forth between squared and cubed, squared and cubed. So really try to think about what you're doing. Okay, to do the volume of a hemisphere is easier than to do the surface area, because what you can do is find the whole volume. Remember, it's the inside of that sphere, as if you filled it up with something. And then to find half of that, you really just need to cut that number in half, and you'll have the volume of half of the sphere. So you don't need to find the area of anything. You don't need to find, there's nothing extra to do, just cut it in half. So let's try it. The volume, 4/3 pi r cubed. They gave us the radius. Awesome. 4/3 pi 6 cubed. Let's put that in our calculator. 4/3 pi 6. I'm going to do this one. Try something different there. Cubed. And 904 point, we're rounding, 8 inches cubed. Yeah, now that's the whole sphere, but I need to break it down. I need, hemisphere. I need half. So 1/2 of 904.8 equals, on my calculator, I could just do divided by 2, 452.4 inches cubed. Okay, and you can kind of visually think, does that look like it's about half of the sphere? Yeah, so you can kind of do a little quick check of your work. All right, so we've got one of each for you to try. One sphere, one hemisphere. It looks like no diameters, so you don't need to worry about that for a little bit. Okay, pause your video and try those. All right, let's see. Volume, 4/3 pi r cubed, which is 5 cubed this time. Pi 5 cubed. Did you get 523.6 feet cubed for that sphere? Perfect. Let's try this one. Volume is 4/3 pi r cubed, and it's 16 cubed. So 4/3 pi 16. I'm gonna try this time. 17,157.3 inches cubed for the whole sphere, but we have a hemisphere. We have the half going, so half of that. Oh my. This is the biggest one I think we've done so far, isn't it? I don't think we've had a number that big. Divided by 2, 8,578.6 inches cubed. Okay, do we match? Awesome. All right, let's do one with some words in it and see if we kind of have enough a grasp of this concept that we can throw words in there. Find the volume of a sphere with a circumference of great circle, which just means the fattest part. So I'm going to look at this. The circumference of the great circle means they took the very center of it. They didn't take a little circle up here, the circumference at the tippy top. They found the circumference down around that very fattest part. A circumference of 25 feet. Okay, so I'm just going to kind of sketch that out. Here's a really good drawing of a sphere, right? There's my center, and then they often draw this little piece around the middle to show that it's three-dimensional. Isn't that just so perfect? Okay, and the circumference, so this circle all the way around this way is 25 feet. Okay, and do you remember what the formula is for circumference? 2 pi r is our circumference. So I'm feeling like if we know the circumference is 25 feet, and we know that's also 2 pi times the radius, we could find out what the radius is, and then use that to plug into the formula to find a sphere. So we're going to have to take that circumference and work it backwards to find the radius, and then work forwards to get to the volume. So let's do that. Circumference is 2 pi r, and it's also 25. Okay, we want to solve for r. We want to know what's that radius, what's that distance from the center to the edge. And 2 pi is just a number. Since these guys are all multiplied together, we'll divide. 2 pi won't be on that side anymore, but we will need our calculator for this other side. 25 divided by 2. Oh, and you know what? You can't type it in your calculator like that. What that does is the calculator will divide 25 by 2 and then multiply by pi. I'll show you. If I do parentheses around my 2 pi, so now I'm saying please divide by this entire sum, we get a different answer. So maybe keep that in mind as you're working. Okay, 3.97. If I round that up, that would round that. Okay, and we would just get 4 if we're rounding to tenths. So I'm going to go ahead and do that. Rounding to tenths, that number comes out to be 4, which we like working with a radius like that, right? Okay, to find the volume, 4/3 pi r cubed, and we know what r is now. What is that radius? Pi 4 cubed. Let's throw that in our calculator. 4/3 pi 4 cubed is 268.1. What were we working here? Feet cubed. Okay, so there's something you might want to think about for later, what a circumference is. And I'm going to let you guys go ahead and get started on the last assignment of the year. Woohoo! All right, I'll see you in class. Bye.